Hi guys, so this is my upgrade solar setup. This is a project I've been working on since like November when I moved to Lagos. It's an upgrade of an existing system. When I was in Abuja, I had a system that I was running for close to 4 years, and so relocating back to Lagos gave me an opportunity to upgrade the systems. And yeah, so this is the whole setup. I For batteries, I have four 12 volts 200 ampere flooded acid batteries, and these are like Exide tubular batteries, and so far so good. They're performing quite well. I ran a capacity test on them yesterday, and they pretty much, you know, did quite well. Like I was able to pull 165 amps while discharging them at C10, and the voltage was 23.3. 23.3 volts when I stopped the capacity test. So what I did was so these are these batteries are connected series parallel. So you have 24 volts, 24 volts. Then I parallel the output. And so what I did for the capacity test was to decouple them, parallel them, and I ran a capacity test on one bank and I ran the capacity test on the other bank. So and they held their own. So I just finished carrying out some maintenance, charger, equalization, and whatnot. This is the inverter. I use it's called iPower Plus, but it's actually an expert MKS 3 kVA inverter, and I've been using this inverter since for close to a year now, and it's a really good inverter. One thing I love about this inverter is that it has a very it's a very efficient inverter, which means that when it's not running any load, it's using about 25 watts, which for me is just amazing. For the charge controllers, I have the Victron MPPT 100 150 volts smart controller. I just got this unit. I was using some other unit before, but I replaced it with the this is an upgrade. Connected to this is I have 9 Yingli 335 watts panel. Unfortunately, those panels are facing the north side because that's the only place in the roof that I have to do the for the installation. So I have some accessories. So for example, the way I connected my batteries was I have two bus bars here, and you have the positive bus bar and you have the negative bus bar, and the system is configured in such a way where every positive connection, so these batteries here, the parallel batteries, so all the positive from the batteries connect to the positive bus bar, and all the negatives from the battery connect to the negative bus bar. I use 25 cable of equal length for this configuration. The whole setup could it be neater, but it's a DIY system, so I have a circuit breaker. This one is between the charge controller and the inverter and the batteries, and then you have the inverter and the battery. These are 125 amps circuit breakers. I also have AC breakers here for the AC, both coming into and going out, input and output. For the solar panel, I have circuit breakers too, so I have them in 3 strings, and I parallel the output. Setup, I have these boxes are kind of like a quasi DIY combiner boxes. So all the strings get paralleled here, the negative get paralleled here, and the positive get paralleled here, but they run through the circuit breaker, so I can isolate each strings, maybe for troubleshooting and whatnot. I also have some other accessories, like there is a Victron battery monitor. So basically what this guy does is to monitor the voltage and the terminal points to monitor the temperature. So it's connected to battery, monitors the temperature of the batteries, and also monitors the voltage. So it senses the voltage of the battery from the terminal point. The reason why this is very useful is that oftentimes there is usually, due to resistance, you find out that the voltage of the battery at terminal is always different from the voltage of the battery when the voltage that the controller sees. So by having this this battery sensor here, Victron calls it the, I think, battery sensor, smart battery sensor or something like that, and it connects to the battery terminal and it's able to get the real accurate voltage of the battery and then sends it to the smart charge controller over Bluetooth. So I have to set up a Bluetooth network. So the controller sees the temperature of the battery and also sees the voltage of the battery and uses that for to adjust when it's, you know, during charging. So it does the temperature compensation thing, so that it uses the temperature of the battery to know how to, you know, limit the amount of voltage that's going into the battery based on the temperature. Lastly, I have some other monitoring devices. So I have a shunt here, and these shunts, basically you have both the inverter and the charge controller, the negative feed from the inverter and the charge controller connected to the shunt. And basically what the shunt does is to let me know how much goes into the battery and comes out of the battery. So basically helps me to monitor it. So I have a Victron battery monitor, which basically checks the system. So right now my system is in float, and there's been pretty much nothing going in or out of the battery, and the battery is 100% full. So with this Victron battery monitor, you pretty much, there's a setting where you configure your battery, you tell it how much capacity you have, the voltage of the battery, and then you put settings like the voltage of the battery when it's full, and, you know, put some parameters there, and it's quite smart. It basically knows you put in the efficiency of your battery. So this is a flooded battery. I set the efficiency to like 87%. If you're using something like AGM, you can set it for like 90%, and if you're using something like lithium, you can set it to like maybe 98% or something. And so it uses that to know, to kind of put into factoring losses when it's calculating how much is going into the battery and how much is coming out of the battery. And that's really nice because it gives me an idea of the battery state, so I can just look at it to see if my battery discharge and what state of discharge the battery is at. Lastly, I have a monitoring device. So this is a Raspberry Pi, and basically what this Raspberry Pi does is to query all the components that I have set up here. It queries the inverter, the charge controller, and the battery monitor. And there is this USB device. You use USB cables that connects to the charge controller and connects to the battery monitor, and it queries them for information and uses that information to know the true state of the system. So for example, for the inverter, it knows how much load the inverter outputs, let me know when the grid is on, how much I'm using from the grid, and the percentage of the load and all that, and I can graph it. So I can send it to my server in the cloud and plot a graph, and these informations are the information are there, they are logged. And the same thing for the charge controller, so I can know things like how much yield I had today, my peak power, and all those other information. And for the battery monitor, for example, I get things like the depth of discharge, the percentage of charge, and so all this information gets sent over the internet to the cloud, where I can get to remotely monitor the system. So yeah, in a nutshell, this is my small DIY project. This project was commissioned in December, and it's pretty it was fun making, and it was quite challenging. So for example, I had to power the Raspberry Pi directly from the battery. I didn't use a power supply because I wanted it to run outside of the inverter. Right now the inverter is off because I ran some equalization, and the inverter could not support the voltage of the battery at such high for such high voltage. The inverter can't support it, so I had to turn it off. But this guy will still be monitoring because I got a power supply from China, And basically this power supply connects to my battery bank, and it's able to power the Raspberry Pi through this USB out. So it supplies 5 volts, 5.2 volts at 3 amps. So it uses that to charge the Raspberry Pi, and basically Raspberry Pi just runs and queries these devices and then send me the data and stuff. So yeah, this is my off-grid solar setup. If you have any suggestion or things I can do to improve the setup, let me know. All right, thanks for watching.